All right, so we have a velocity vector, the horizontal component and the vertical component, and we have an initial position of 3, -5. So we want to know what the position is at time t. The position at time t will be where it is at time 0, which is 3, -5, plus displacement, which will be a vector. It'll have a horizontal component and a vertical component. All right, recall that displacement is equal to the definite integral of distance, which is velocity times time. Velocity is usually a function of time itself times time, as time goes from some initial value to some ending value. Well, in this problem, we are starting at t equals 0, and we're ending at t equals t. But if our upper limit of our integral is t, then our integrand and the variable with that we are integrating with respect to can't be t. So we have to make a little adjustment. Remember that definite integrals are just constants. A definite integral is just a constant. It's a value. And the variable that we use is a dummy variable. It's often called a dummy variable because it really isn't meaningful in calculating the constant. Whether we do x or m or theta makes no difference. Do the antiderivative and use the fundamental theorem of calculus, and we get 8 in every case. So when you have a definite integral, the letter that you use really doesn't matter. It's a dummy variable. In our definite integrals, t isn't really a variable at all, right? We're doing a definite integral from some numerical value to some numerical value. It is the endpoint. It's not really taking on other values. It's a constant. So we can't reuse t in the integrand. And that's why you can see that we've gone to some other variable, and the choice of s was arbitrary. Again, it's a dummy variable for definite integrals. So the displacement is going to use the horizontal rate of change, which is t squared, and the vertical rate of change, which is e to the negative 2t. But we will use s instead of t. So these definite integrals will be exactly what they would have been with any letter in here. And our upper limit is t because we're going from t equals 0 to t equals t. All right. When we add these to this original position vector, we'll have our answer. There it is, answer choice C.